Hello guys, welcome to algebra class. This time I will go over absolute value transformation. I believe most of you have understood this lesson, but I'm just making this video for people who missed my class, okay? So let's talk about key attributes of this absolute value graph. You see this V-shaped graph, right? First question, it is asking find solution. So basically, another name for solution is x-intercept. Although math teachers will not use x-intercept on their test, they will use solutions, roots, or zeros as alternative words. So let's do this one by one. This and these points, these are what we call solutions. So we have one at -5, 0, another one at -1, 0. Okay, now we have to look for y-intercept. Y-intercept is where this graph touches y-axis, and this graph touches y-axis at here, and it goes like 0 to 4. So this point should be 1, which is 0, 1. Axis of symmetry. This is a line that cuts parabola or any graph in half. As you can see, this line will cut this graph in half. Therefore, this line is going to be the axis of symmetry because it's a line. And as you can see, this one is touching at where x is equal to -3. So we will call x equals -3. Vertex. Vertex is either highest or lowest point. And this point is going to be the lowest point of the graph. That's going to be the vertex. This is located at -3, -2. As you can see, your axis of symmetry will always cut through this vertex. So first number of the vertex is going to be the always axis of symmetry. Now, pause the video. We're going to talk about domain and range later. I want you guys to try this one by yourself. So now pause the video and do it by yourself. And I'll write down the solution. That's it. I hope you guys got right on this question. So domain and range. By definition, domain is set of all x values. So if you look at this graph, this one is all possible x values. But look at this. Where does it stop? It will not stop at -8. It will continue to go to left. So this one is it will keep going to -infinity side because it's keep going to the left. Never stops. Same thing. If you look at the right side of this graph, it's keep going to the right to the positive infinity. In another way, we can call it a real number. Now, when you're doing domain and range, what you have to be careful is if you have something like this, open circle, you use parentheses, arrows, or infinity, you always use infinity. But if you have a closed circle and something like that, closed circle is a bracket because it is closed, which means included, but parentheses for the arrow, like that, okay? So it can coexist like this, or any points on the line is considered as closed. Why do we talk about this? Because of the range. Range is set of all y values. We're going to talk about bottom to top, always bottom first. So this graph can keep go down, but it's going to stop here and bounce back, which means this is going to be the lowest point, which is -2. But this point is on the line, so it is considered as closed, comma. What's the highest point? It's keep going up, and it will never stop, so it's going to go to positive infinity because it's keep going up. So that's the range. Now, I want you guys to try this one by yourself. Pause the video and try it by yourself. That's it. Now range, I'm pretty sure many of you have made a mistake on here because range bottom to top is keep going down. That's why I put negative infinity. It's keep going up, but do you see it cannot go above here? It bounced back to the down. So 5 is the highest point and it's closed because it is on the line. So these are the key attributes. Now let's talk about the transformation of absolute value. We start from its parent function, which is y equals absolute value of x. That's our parent function. Now, how does this each component work? Now, when it comes to a, if a is greater than 1, we call it vertical stretch. Which means your graph is going to go narrow. If a is smaller than 1, not too negative, what I mean is fractions such as 1/2, we call it vertical compression. I don't have enough space, I will write. Or you call it vertically compressed, okay? Which means your graph is look wider. And it's gonna be simple from now on. Any number inside the absolute value, so if you look at this h, if it's a positive, it's gonna work opposite direction, which is it's gonna move to the left. If it's negative, it's gonna move to the right. Only because there's a negative already. And if you look at here, k, it's the vertical shift, which means if it's plus, it's gonna go up. If it's minus, it's gonna go down. So pause the video, copy this one down, and you will see what I mean. So let's do one question together. We're gonna do this one from y equals x. You can actually use decimals like this. I'm gonna put y equals absolute value of x and y equals absolute value of x twice, one top and one bottom. So top one is the original, bottom one is what we are about to change. So let's do this. We first have -4. As you can see, from the red to blue, it moved 4 units to the right. This one is the horizontal shift. And if you put -7 at the end, this one, as you can see, it moved down by 7 units. And that's it. So you can use decimals, although later when you get used to it, you don't need it. It's really easy. So try this question by yourself. I hope you got this question correct. Right, so that's about it. Rest of them are just straightforward. I will just go over this question. Oh, never mind. Now, this 3. Now we have number in front of the absolute value. So let's see what happens. 3. This one is a bigger than 1. So as I explained earlier, as you can see, this one got narrow, right? Because you're stretching it vertically. What I mean stretching vertically is you stretch it out like this. Do you see this graph is going to get narrower once I stretch it vertically? So we call it vertically stretched by factor of 3. And +1 should be easy. It's same. +1 is 1 to the left because it's left and right will work opposite direction. -4 is going to move 4 down. 1/2. On the other hand, 1/2 is smaller than 1. So as you can see, if you put 1/2, this one is wider. So we call it, this one's the vertically compressed by 1/2. And -3 is going to be 3 to the right. Okay, what's going on? And -4 is 4 units down. Yep. I'm pretty sure you guys can do other questions by yourself. And here, I think these 2 are the last question that we'll go over, only because of the negatives. It's a new concept. So now if you put negative, look at the decimals, what happens. As you can see, it has flipped over x-axis. So negative, whenever you see negative, we always write reflect over x-axis. Okay. Now 2. When you put 2, this one, you may think negative 2 is smaller than 1, so it should be widened. But as you can see, this one's a slightly shrink, like compressed, right? Because negative sign, we don't really care. What we care is just number 2. And that's bigger than 1, so it's still vertically stretched by 2, okay? And plus 3 is going to be 3 to the left. And apparently, there's no up and down. Now, let's do this one. Negative. This one is, again, reflect across x-axis. 7 over 3 is bigger than 1 because it's 2.3, so I will call vertically stretched by 7 over 3. Plus 4 is up 4. So I believe you guys can do the rest of the questions by yourself. If you have any question, just let me know. I'll help you. So now, pause the video, try this 4 questions by yourself, and then check your answer. For third is bigger than 1, so it's vertically stretched. That's it. I hope this video helps you. That's about it, guys. See you.